Let's look at what makes up container images and how we build them. This diagram shows the development process of a running container. A Docker file is the blueprint from which an image is built. The Docker file outlines all the steps to be taken to build the desired image. Docker then builds the image. It's important to note the difference between a container and an image, which can also be called a container image. These are not interchangeable terms, but rather two distinct things. An image is an immutable file that contains the source code, libraries, and dependencies that are necessary for an application to run. That immutability means that images are read-only. If you change an image, you create a new image. In a sense, images are templates or blueprints for a container. You can also think of images as snapshots of a container. A container is therefore a running image. Since images are read-only, a write layer is placed on top of images to enable the container to execute. To relate this to object-oriented programming, a container is like a class, and a container is an instantiated object of that class. As this diagram shows, you begin with a Docker file that indicates what to include in an image. You build an image using that Docker file. Then, when you run that image, you have a running container. These are the three basic steps in the container development process. Docker can automatically build container images by using the instructions from a Docker file. A Docker file is simply a text file that contains all of the commands a user would call on the command line to create the image. We'll learn more about them shortly. Docker provides a set of instructions that make this process a bit more straightforward. Images are then built layer by layer, with each Docker instruction creating a new layer on top of the existing layers. It looks something like this. As Docker instructions are run, new read-only layers are created for the image. Depending on the size of an image, there can be a few layers or many. In this example, we have 4 layers. When all the Docker instructions from a Docker file have been executed, the image is built and complete. Again, this is a read-only image. Making a change would result in a new image. As we just observed, running an image results in a container. When we instantiate this image, we get a running container. At this point, a writable container layer is added on top of the read-only layers. Remember, containers are not immutable like images are. Containers are running, performing operations, and performing whatever function the developers have written. This writable layer enables the container to execute its function. Note that layers can be shared between images. If 2 images have a layer in common, that layer can be used by both images without having to recreate it. This can save a lot of disk space and network bandwidth when sending and receiving images. There are several instructions recognized and provided by Docker for use in Docker files. Any valid Docker file must first begin with a from instruction, which initializes a new build stage and specifies the base image that subsequent instructions will build on. This base image is often from a public repository, like an operating system, or a base image for a specific language like Go or Node.js. This base image is the starting point for the rest of your image. Let's go over some other instructions that Docker provides. The run instruction executes commands. So, for example, you can put a bash command in a run instruction to perform a desired action. Each instruction is a new layer added on top of your previous layers. The env command enables you to set environment variables in the image. The add and copy commands are similar and enable you to copy files into your image. You would use this to, for example, put your application code or executable into your image. The main difference between these two is that copy can only copy local files and directories, and add can also add files from remote URLs. Then there's the CMD instruction. There can only be one CMD instruction in a Docker file. If you include more than one, only the last one will take effect. The main purpose for this instruction is to provide a default for executing a container. This instruction often defines the executable that should run in your container. Let's have a look at a Docker file to see these commands in action. Here is a simple Docker file. Note that the first command, as always, is a from command. Remember that this command defines the base image. In this case, our base image is Ubuntu version 18.04. This image is freely available on Docker Hub, so we don't need any authorization, and we can also omit the host name. Next is the copy command. This command copies the contents of the current working directory into the app directory as a new image layer. The run command performs a make operation to build the application. Finally, the cmd instruction provides a default mechanism for running this container. In this instance, the Python application will be run. As you can see, Docker files are simple to construct and use. There are more advanced patterns for optimizing your Docker files and building images more efficiently, but in general, these basic operations open you to the powerful world of containerization. You should now be familiar with how to build container images using Docker files. You should understand how images are made up of layers and how those layers relate to Docker file instructions. You should also know the difference between containers and images. In the next video, you'll learn about using container registries to store container images.